Welcome. Welcome to topic 3 in our course, Evolution in the Human Mind. In fact, I'm thinking of changing the name of this course to The Meaning of Life for the 21st Century. I thought that might say more about it in terms of the outcomes of the course. So today we're going to be talking about evolution by natural selection. And why do we need to learn about natural selection? Well, firstly, Darwin's theories were revolutionary. In other words, although other people had been thinking along the lines of natural selection for a while, none of them had actually gone to print in terms of developing a full-blown theory and then publishing it. And the thing that was revolutionary about Darwin's theories were that they relied only on natural processes. It didn't require any supernatural intervention at any point of the stage, in any point of the process. And Darwin's theories form the basis of modern biology. And this is partly about modern biology and how it relates to the human mind. And it's necessary for understanding evolutionary psychology. So you can't understand evolutionary psychology or even comprehend evolutionary psychology unless you know the basics of natural selection as put forward by Darwin. Now, in this little talk, we're going to look at a brief biography of Charles Darwin, and Darwin's theory of natural selection and his theory of sexual selection. Which sounds a bit risque, but it's not so much when you get to hear about it. And then finally we'll look at what's happened after Darwin, or the things that Darwin didn't know at the time. Okay. Now, brief biography of Charles Darwin. He was born in 1809 in England to a wealthy, semi-wealthy, middle class, upper middle class family. They were reasonably well off, and they could afford to send him to Cambridge, and he got a Bachelor of Arts in Theology at Cambridge, only because his father was a minister, a Church of England minister. And although he went through and got his Bachelor of Arts in Theology, possibly with the possible intention of becoming a Church of England minister, his real interest was in naturalism and geology. When I say naturalism, study of the natural world, and in geology, study of the formation of the earth. And not long after his graduation, he was recommended to be the naturalist and geologist on a British Navy ship called HMS Beagle, which spent 5 years traveling around South America and the eastern part of the Pacific. And during that time, he had a lot of opportunities to study nature and study geology in many different environments. In 1836, he returned to England and just took up continuing to study the specimens that he picked up on the trip. And in the meanwhile, his reputation as a naturalist increased. And he joined the Royal Society, which was the premier British scientific body. In 1839, he published a book called The Voyage of the Beagle, in which he set forth the trip and what he found on the trip as far as collecting specimens goes. But he didn't say anything about natural selection, about evolution at that stage. He needed to work on that a bit more. He needed to get it really tightly sewn up before exposing it to public light. And he continued to work on his favourite topic, which was barnacles. So he became a world expert on barnacles while he was putting together his theory of natural selection. And in spite of his friends and colleagues urging him to publish, he refused to do so until he was absolutely certain that he had a good watertight theory of evolution. In 1858, he learned that there was another guy called Alfred Russel Wallace who had been sailing the world at his own expense. But unfortunately, Alfred Russel Wallace couldn't be classified as a gentleman, therefore wasn't really a member of the Royal Society. However, Alfred Russel Wallace sent a paper to Darwin for Darwin to peruse, and it was all about his theory of natural selection. So it looked like Alfred Russel Wallace was closer to publishing than Darwin was. And Darwin's Royal Society friends didn't want Darwin to be pipped at the post, so they suggested to Darwin that he publish immediately. So he wrote up a short paper. However, he insisted that his paper and Alfred Russel Wallace's paper be read to the Royal Society simultaneously. I guess that was because he had a sense of justice. He wanted the justice to be done, that Alfred Russel Wallace wasn't going to be sort of gazumped and have his work sidelined. However, his friends prevailed upon him to publish quickly, so he published his book On the Origin of Species, and of course got it out there before Alfred Russel Wallace got his theories out into the public. And of course, the book On the Origin of Species created an uproar, particularly in the church, because it really got out of the equation, and there weren't many people in the world at that stage, or in England at least, who were capable of imagining a world without God. In other words, God had to be there. He had to create things. He had to make things go. And if God didn't make things go, then they wouldn't go. However, in order not to upset the apple cart too much, he left the human species out of his book, The Origin of Species. So he left room for, the people to say, well, no, this only applies to monkeys and gorillas and four-legged animals and birds and things. It doesn't apply to two-legged animals like us, people. Well, I suppose chooks are two-legged, aren't they? Don't worry about that. But later on in 1871, after a lot of urging from some of his closest friends, he published a book called The Descent of Man, in which he laid down the same natural selection rules for the human race, the human species. And also, he mentioned a thing called sexual selection, although his title of his book was called The Descent of Man and Selection in Relation to Sex, which sounds a bit, like I said, a bit risque. However, I guess it did have a relationship to sex, is what happened before sex itself. And this was a quite revolutionary, more revolutionary than the previous book. It couldn't be put back in the box. You know, once it was out of the box, it was out, and that was it. And in 1882, he died. But in the meanwhile, excuse me, I got a bit of a runny nose today. It's a bit cold here, and my nose tends to run a bit when it's cold. Sorry about that. a bit basic. And in the latter half of Darwin's life and beyond, a thing called social Darwinism evolved. Not evolved, but sort of was created. And this is where some unscrupulous people used Darwin's principle of natural selection to say that might is right. In other words, the British nation had the right to rule the world because it was the survival of the fittest. They were the fittest. Therefore, it was right and true that they ruled all the other races on Earth if they possibly could at least the other Europeans as well, they could get a hand in it as well. Because we were the superior races, and being the superior races, then natural selection said that we had the right to get rid of the non-superior ones. This, of course, had nothing to do with Darwin, and Darwin repudiated it, and Darwin's closest colleagues repudiated it. But this Darwin, this social Darwinism made a big impact on the first half of the 20th century with people like the Nazis and other fascists who thought that they were the pinnacle of human evolution, and therefore had the right to subjugate and often eliminate other non-evolved parts of the human race. Okay, so moving on to the actual theory of natural selection. And we need to know a bit about this before we can know what's happening in the rest of the course. And Darwin put forward two theories. His first theory was that species change over time. And he got the evidence for this from the geological record, fossil record. And the other thing was natural selection, how species change over time through natural selection. In other words, when a natural event occurs or the environment changes, the members of the species that are better adapted or better suited to cope with that environment are going to prevail. They're going to live, they're going to produce more babies, and those babies are going to produce more babies. So whatever the trait was, the ability was that these people had that enabled them to survive that environment was passed on and grew exponentially, bigger and bigger and bigger. And thinking about it, that means that we, sitting here now, are the what do you call it, the descendants of the human beings that managed to knock all the other human beings on the head and be the winners. So we were the ones that came out on top. And of course, these adaptations did not happen with any guiding intelligence. There's no intelligence behind it, and it was merely a process, a natural process that occurred, and there was no guiding hand. It wasn't the solving of a problem. It was just that in that environment, people with these physical and behavioural traits were more likely to survive than people who didn't have those traits. Okay, now getting on to the prerequisites for natural selection. There's 4 prerequisites. There's variety, heredity, fecundity, and demography. Variety means the members of the species are not identical. There's variation in them. Heredity means that the species must have heritable traits. In other words, it passes down physical and behavioural traits to the next generation. And they, of course, pass it on further. Fecundity means that the parent animals must produce more babies than just the 2 of them. In other words, each generation has to be larger than the previous generation. If it's not, then the species is likely to die out, and that makes us wonder about the declining birth rate in the Western world. And of course, in China, they had an official policy, which I don't know that it worked that well. And if we have a declining birth rate, then we're not going to be following the 3rd law or the 3rd requirement for natural selection. The parent animals of the species must more than replace themselves. And the last thing, demography, means that there's a competition for resources, and it's the ones who win that competition that survive. In other words, if there's a limited amount of resource in the environment, it's the ones that have whatever it takes to sort of corner the market in that resource that survive, and those that don't survive so well. And as I said, the adaptive traits, once they get through a particular environmental crisis, just increase and they become more common with time until a new crisis comes along, a new environmental crisis, in which case those particular adaptive traits may not be applicable anymore. And that particular environmental change requires new adaptive traits. But remember, it's not that these things were created at the time. It's just by sheer accident through mutation, through genetic mutation, although Darwin didn't know about genetics, but through genetic mutation, that some animals will have qualities that fit them for the new environment and some won't. And the ones that do will survive and the ones that don't won't. And it's not about survival of the fittest. It has nothing to do with survival of the fittest. It's to do with survival to reproduce. So the people who reproduce more pass on their genes more, and they're the ones that those particular, what do you call it, traits, heritable traits, are passed on and on and on and on. Okay, and what else? Yep, that's about that. Moving on. Of course, now traits, as I said, traits are passed down by natural selection, and there's no planning to it. There's no intelligence behind it. It's just sheer accident, sheer chance that some people have mutations that fit them for a particular new environment, and those that, like I said, those who don't have those mutations are not likely to survive long. So, like I said, there's no design behind it. There's no purpose, and it's not a solution to a problem. It's not as if a problem pops up, or a new environment pops up, and the species somehow says, what qualities do we need to survive in this environment? And then it goes and produces it. No, it doesn't work that way. It's sheer accident, sheer chance. So it's only a natural process that has no purpose or design or guidance to it at all. Now, determining what traits, physical and behavioral, are an adaptation means that you must look back to the environment in which these traits were likely to have evolved and say, did these traits add to the survival and reproduction of the species at that particular time? And if you can say without any shadow of a doubt that they did, then we can classify that particular physical or behavioral trait as a evolutionary adaptation. Now, these adaptations come in three categories. There are the actual real live adaptations, the ones that really did help us adapt, and that's like the suckling reflex in a baby. Now, in babies who didn't have the suckling reflex didn't survive. Those that did survived, and no one teaches them. They don't get a little lesson when they hop out of the womb saying, now this is what you have to do next. No, it doesn't work that way. They hop out, they find the breast, and when they found the breast, then they latch onto it and immediately start sucking. So it's a heritable trait. Now you can have side effects. Thumb sucking is something that sort of is related to nipple sucking. However, it's only a side effect. It doesn't have a survival benefit, unless you think that people who suck their thumbs as children grow up to be calmer adults. Personally, I don't think they do. I think it's probably the opposite is true. And then there are accidents. And for example, the one that's oft quoted is that human beings, when they clasp their hands together, have a tendency to put the left thumb on top because it feels comfortable. But whenever in a class I use this as an example, I say, put your hands together and see which thumb is on top. You can bet your bottom dollar that half the class will have their right thumb on top. So I don't know how that works. Anyhow, you got the three types: the adaptations, the adaptations that really do enable survival. You got the side effects from that, and then you got pure accidents, things things that happen that are passed down from generation to generation, but they don't really have any effect on our survivability, unless there is a reason for left thumbs being on top, but I haven't been able to work that one out. Now, our DNA, remembering that Darwin didn't know about DNA, he just knew about heritable traits, knew that animal or baby animals inherited things from their parents' instincts, or whatever you like to call it, physical characteristics and instincts. These are only aimed towards, well, I shouldn't use the word aimed, they result in survival and reproduction. So our heritable traits are only concerned with survival and reproduction. They have nothing to do with happiness or well-being. So putting it in modern terms, our genes aren't in the least bit concerned whether we're happy or not. And if you think about people getting together and becoming parents, if you have had a lot of experience of families, you'll know that some people should never, ever have babies because they're terrible parents. I mean, they've got no idea how to be an effective parent. However, in spite of that, the human race has managed to survive and continue. So it's not about are you a good parent? It's about are you able to pass your DNA on, and that's the only criteria. And of course, happiness and well-being does not come into it. It's not in the equation. Happiness and well-being doesn't even come from obeying our basic instincts, because our basic instincts are only aim towards making babies and raising them to the point where they can make babies. And beyond that, they're not much use at all. In fact, these instincts or these behaviours, these heritable traits that make us do these things, in fact, are a hindrance to happiness and well-being outside of actual reproduction. So having developed intelligence, not a lot of wisdom, of course, the human race doesn't have a lot of wisdom, but has a lot of intelligence. Having developed the ability of self-consciousness, we're one of the few species that has. We don't know how many others have it because they haven't been able to, they don't write books and they haven't told us. But we know that we have self-consciousness. We can sit down and we can think of ourselves. We can look inward. We can be aware of ourselves as well as other people. So having developed that, we then began to become aware of whether we were happy or unhappy. And our natural selection is not in the least bit interested in whether we're happy or unhappy. We've got to sort that one out for ourselves with our intelligent brains. Now, the trouble with human beings is, along with our intelligent brains, we develop a neurological agency detector. In other words, in our brains, we've got this capacity to see something and attribute causation to it. In other words, that thing has the power to do this, or there's some power behind that, or there's some authority or whatever behind that particular thing happening. It's very hard for us to get our minds around the idea that a process could happen that wasn't started by anybody or guided by anybody. It's like we have a inbuilt tendency to always look for what caused or what started it or what produced this or what designed that, and it has to be some sort of intelligence. So we attribute intelligence to all sorts of things like spirits, gods, devils, angels. So we have to find a cause for everything that happens. We cannot accept that there is no cause. We cannot accept there's just sheer chance and just a natural process. It's very, very hard for us to do. So you'll find that even when I'm talking about natural selection in coming talks, that I will slip into the it was intended, that it was designed, or blah, 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 because that's like a knee-jerk reaction. We automatically think in terms of design and intention. It's like the fallacy of the watchmaker. In other words, again, in the 18th century and early 19th centuries, and probably beyond, maybe even into the early 20th century, people were saying things like, well, if you just look at the complexity of life on Earth, there has to be a guiding hand. Like you couldn't have a watch without a watchmaker. It couldn't just fall together all by itself. And that's a very convincing argument if you think in terms of a human lifetime. In one human lifetime, is it 70 years or so? Okay, well, what's the chance of the components of a watch falling together, I mean, actually coming out of the earth and finding their way together and coming together as a watch and then starting to tick and keeping accurate time? Zero. It's absolutely zero. But if you think in terms of 6 million years, it changes the whole equation. In 6 million years, lots and lots of changes can occur. There are lots of processes, like random, even accidental processes that can make things change and become functional. And those that aren't functional don't survive. They don't evolve. It's only the ones that actually worked that survive. And the ones that survive actually work out reasonably well, but they don't work perfectly. I mean, some of the bodily functions of the human beings could have been designed much better. Any surgeon will tell you that. That our evolution isn't perfect. In other words, it's like evolution builds on what's already there. So if something's proved to be not so great before, then suddenly it becomes it gets built on, and then it becomes functional. So it's like, in order to make it functional, the old has to be converted somehow, but it's not removed. It's still a problem. Well, it's not a problem. It's still imperfect. Like our eyes. Our eyes are far from perfect as a seeing system. They could have been designed much more efficiently. However, they haven't, because we evolved through a gradual process of something working and it being used as the basis for the next stage, and then that being used as the basis for the next stage. So we have remnants of the stages that weren't so good, still in us. It's like our brains. We got the reptilian brain, and we got the mammalian brain, and then we got the human brain on top of that. So we still have the old, and you think if we'd been designed from scratch, but from scratch by a watchmaker or an intelligence of some sort, if they knew what they were doing, they wouldn't have given us a reptilian brain and a mammalian brain. They'd just given us a human brain. And that would have been enough. Okay. And with this agency detector, the need to look for purpose in everything and a cause for everything. One of the reasons for that was that when we're in the evolutionary environment and we're being threatened by some big creature that wants to have us for lunch, then it's better to have a false positive than a false negative. In other words, if we look at that thing and say that thing has bad intentions towards us, and you run like mad to get out of there or climb a tree, that's much better, even if it's not true, than if you have a false negative, which is you look at that thing and say, oh, it means well. There's no need to run, but it doesn't mean well. It actually wants to go eat you for lunch. So it's better to have false positives than false negatives. So that's where our agency detector has become overactive. We have an overactive agency detector. We want to find intelligence in everything, so that we know whether to run or not run, as the case may be. Okay, now talking about sexual selection. And of course, Darwin added this last. That was the last thing he added to his theory. And it's based on the fact that when it comes to having babies, finding a mate to have a baby with, the females of all species, not just the human species, are choosy. And the reason for that is that they don't produce as many eggs in a lifetime as the male of the species produces sperm. So a female only gets a certain number of chances to produce a baby, and they want to make sure they get it as close as possible to right each time. And also the female has the biggest investment in having the baby and in raising the baby. So it's like they're going to spend most of their life, and well, particularly back in evolutionary times, they probably spent all of their life raising their children, because they didn't last much longer after that. So females are choosy, which meant that they'd look at a male. We're talking about all species now, not just the human species. They look at a male and say, right, now, is this male going to produce good babies? Will my babies by him be superior to my babies by some other male? So whatever trait a male had, like peacocks, for example, this fancy tail, big fancy tail that they have. Once upon a time, those tails weren't so big; they were small. But what happened was that over time, female peacocks or peahens found these tails very attractive, and they thought they were a sign of health and well-being, and that they would pass their qualities on to any offspring. I mean, this is not thought consciously. Species don't think this, even the human species doesn't think this consciously. I mean, when a girl's out looking for a guy to get engaged to, get married to, if that still happens these days, then she's not thinking, well, who's going to be the best father for my children? No, very rarely does that happen. There's lots of other considerations that come into the equation before that. However, behind it all, as far as our DNA is concerned, that's what's behind all the other considerations. All the other considerations are like a smokescreen to cover up the real consideration. The real consideration is this male going to be an appropriate father for my children? And because the females are choosy, and it might become fashionable to choose, if a peahen, it becomes fashionable to choose a male with a big tail. Males over many generations produce bigger and bigger tails because the males with smaller tails aren't getting mates. So the small-tailed peacocks don't pass their genes on. It's only the big-tailed ones that pass their genes on, and over time the tails get bigger and bigger and bigger. And all of this happens not through a process of natural selection; it happens through a process of, you might say, gender or sexual selection. That the female prefers a particular type of male with a particular trait, and because that's happening more often than not, then that particular male passes his traits onto the next generation, and so it goes on and on and on. Which means that the female of the species, male, human or not, have a big say in what future males look like. Not that they know they're doing that, but that's what happens. Okay, so moving on. Now, looking at beyond Darwin, something like some of the gaps in Darwin's knowledge. Just tend to this nose of mine. There we go. Darwin didn't know about genetics. He didn't know about genes and how they work. A lot of bodily functions that Darwin didn't know about. So he just knew that the things were passed on from generation to generation, and there was some sort of mutation effect going on, so that in a particular generation there'd be a mutation, and that would produce a physical and or behavioural change in that particular member of the species, and that later on may become very, very useful in an environment that changes in a negative, in a negative way for the current model. Darwin thought that natural selection only happens slowly. In fact, it can happen very fast. Not always, but it can. It can be quick selection. And one of the examples of that is that before the Industrial Revolution in England, moths that were dark-coloured got eaten first because they stood out against the background. And the moths that were light coloured tend to survive better, and they bred more. After the Industrial Revolution, when the environment started to turn dark through soot and pollution, right up till about 50 years ago, the moths that were dark had a survival advantage because the birds coming along wouldn't see the dark ones against the background. They'd see the light ones against the background. So the light ones started to get eaten, and they weren't breeding as much as the dark ones were. Then about 50 years ago, when we started cleaning up our act, and the colour of the world started to change from dark black to what we have now, then the light moths are coming back. In England, the darker ones are getting eaten because they're now highlighted against a lighter background, and the lighter moths don't get eaten as much. So we're going back to a light-coloured moth being, and that's what happened over a matter of a couple of 100 years. And Darwin found that on the Galapagos Islands, that there were different species of birds or finches that looked similar, but they were actually quite different. They turned into new species. And that had only happened over a matter of 1,000 years or so. Like, didn't take 1,000,000 years to do. And another thing that Darwin didn't talk about was how new species are created, how that happens. And we'll find out more about that later. We won't go into it now. But there are certain criteria that are required for a species to become to split off into a new species. And in the fossil record, contrary to Darwin's thoughts, there have been sudden increases as well as slow ones. So there have been sudden increases in species and decreases in species, and in the change in species. So it's not all slow. You can have slow and fast. And finally, he didn't know that evolution is complex, not linear. In other words, it doesn't go from A, B, C, D, E. It sort of goes A minus A plus, A, B, 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 A. For example, the human species split from the ape species that us and chimpanzees branched off 2 million years ago. And on our way to becoming Homo sapiens, we've discovered at least 13 different branches on the humanoid tree. In other words, there were 13 totally different species of humans in that time. And the last ones died out about 20,000 years ago. That was the Neanderthals in Europe and the mob called the Denisovans in Siberia. Now, whether they died out through environmental causes or because Homo sapiens had learned to become more aggressive and take over their territories and deny them food or whatever the cause was, they died out. And 20,000 years ago isn't that long, really, when you think about it. When the Australian Aborigine has been here for 60,000 years at least. So 20,000 years is, not much. Okay. So yes, so evolution isn't linear. It's not straight. It takes many different curves. If you look at a tree, particularly a eucalyptus tree, I often go in the bush in the mornings. I go for this bush walk. Got quite a good track locally, and I go down to where there's a good stand of trees, and I look up, and the branches are higgledy-piggledy all over the place, all twisted and turning, and there's no rhyme or reason to them. And species actually evolve like that. They go off in all sorts of directions because it's the natural selection process at work, and it will pop up different things at different times. Different mutations will pop up in different environments, and that will cause this to occur, and something new to pop up over here, but not over there because that's a different environment. So it all gets quite messy and complex. It's not simple. Okay, so that's our lot for today. And just to briefly run through it, we're doing all of this because we need to know about natural selection in order to do evolutionary psychology, and we'll be going more deeply into it later. And Charles Darwin had a big hand in doing that. And in order to have natural selection, there are certain things you have to have. Remember, there was variety. The people aren't identical. The members of the species aren't identical. Heredity, there must be traits that are passed down. And the parent animals must create more children than just themselves. In other words, they must have at least 3, not 2. And in resource competition, it's the survive. It's the ones who corner most of the resources that survive. And so moving down, and then we had sexual selection, where the female of the species has a big hand in creating the look of the male of the future, not because they want to, because they intend to. It's just a natural process that they're driven by their DNA to find the male that is best going to give their children the best opportunities as far as DNA is concerned. Not that anyone knows about DNA. I mean, I don't think anyone who becomes a parent is thinking about DNA. They're thinking about other things when they're making babies, not the DNA. And then coming down, and then of course there were a lot of things that Darwin didn't know, and like genetics, and we'll be getting into genetics as well, and saying more about that and how that works. Okay, well, it's been nice talking to you, and I'll see you again next time. At least I won't see you. I'll talk to you again next time. Bye.